All right, hello guys. I'm a mathematician. I'm actually not a scientist. So what I want to do today is just tell you a little bit about what it is that I do all day as a mathematician. That is my research. So I don't have any data or labs or experiments, or I don't even use a computer. Most of the time I'm just sitting there writing math all day long. I study something called the nonlinear Schrödinger equation. You may have heard of Schrödinger's cat, same guy. Okay. Physicists in the room. So linear Schrödinger equation, basic Schrödinger equation tells you what one particle is doing. Particles are slippery and complicated, but we know how they act based on Schrödinger equation. Nonlinear Schrödinger equation will tell us how a group of particles are acting. So I'm studying many particles. Particles are maybe a little challenging to visualize, so we can just think about you people in this room as being particles. Let's imagine we just have one particle. You're a single solitary particle. You're kind of a free spirit. Particles have this innate desire to sort of wander and explore the world. If I were to set you down and turn around, when I turn back, I have no idea where you've gone. You probably wandered off. Now, what I want to do is take many of you particles, put you together, all in some cloud. Now, my equation takes into account the interactions between all of these particles. Perhaps the particles maybe don't like each other. I can set it up so the particles don't like each other. So imagine you have all these free spirits who just want to roam, and they really don't like each other. You can imagine that they're just going to get out. They're all going to find their own little piece of nowhere and just wander around and be happy. This is a so-called scattering theory. This is something I study. You can imagine I may try to prove a theorem saying, no matter how I arrange you difficult people, you will always just run away and scatter. You will just scatter. That's one example. Another example, you can imagine maybe you guys really like each other. Maybe particles really like each other. So much so that you no longer want to run away. You just all come together and smush right into some singularity. You form some black hole. You just all explode together. This is a so-called blow-up theory. This is another thing that can happen. You study the breakdown of the equation, the explosion. Now, the most interesting thing for me is a kind of middle point. You can imagine these two competing forces may balance. So you, on the one hand, want to roam free, but on the other hand, you like the other particles, you want to stay near them. Maybe I can get you all into some very special configuration such that you are stable. You just sit there and nothing is going on. That would be really nice to have this equilibrium position. This is a so-called soliton. I like to study solitons. I like to know what they're doing. The most interesting questions for me are, what happens if I perturb them a little bit? Let's say you are all happy, you're all happy particles, you're all together, you're in your comfortable equilibrium position, and I come over and I push one of you, or I put some new person in, or I insist that you all kind of move around a little bit. Change the system just a little bit. We can ask ourselves what's going to happen. Maybe this perturbation is going to cause all of you to get too close to each other. You don't like it, you all run away, everyone scatters. Conceivably, you get closer to someone, maybe you really like that person, and you get sucked together and explode. Most interesting would be if I push you around a little bit, maybe you all wobble a little bit, but eventually you find sort of a comfortable position, and you all sink back down and reform the soliton. This soliton I would call stable. This is an example of stability theory. So this is something I like to study. So I guess putting everything together, I study long-time behavior of solutions to this equation. I study the stability of solitons. I figure out what these particles are doing.